Torque? What is that? And what does it have to do with this bike? All of that on today's episode of Before I forget, do not Google how to torque.
Before we can know how torque applies to bikes, specifically bicycle gears, we must know what torque is.
Torque is the measurement of a force that is acting on an object and causing it to rotate. The unit it's measured in is a Newton meter, or kilograms a meter squared per second squared.
Torque is calculated by taking the radius from the axis of rotation to the point where the force is perpendicularly applied, then multiplying it by the applied force and sine of the angle between the applied force and position vector.
Alright, now that we understand what torque is and how it's calculated, let's see how it applies to the gears of a bicycle. For simplicity purposes, in our calculations, we're going to assume the force being applied is at a perfect 90-degree angle to the pedal. To start off, let's put the bike in 7th gear.
Here, we can see when we crank the pedal, it makes this chain rotate around the chain wheel and the sprocket on the rear wheel, thereby rotating the rear wheel.
Let's start by calculating the torque from the force applied to the pedal. The radius from the axis of rotation to the point where the force is applied on the pedal is 0.1778 meters. We'll multiply this by the force being applied to the pedal. In our scenario, we'll say that the biker is putting all of their weight on the pedal at 90 degrees with no extra force. If they are 68 kilograms, the force they are applying is about 680 newtons. These multiplied together give you the torque of 120.904 newton meters.
Awesome. Now that we have the torque, let's see what we can do with it. If we take the torque and divide it by the radius of the chain wheel, this gives us the tension of the chain. So 120.904 newton meters divided by 0.0889 meters gives us a tension of 1,360 newtons.
With the tension of the chain, we are able to calculate the torque around the sprocket on the back wheel of the bike. This is done by taking the tension of the chain and multiplying it by the radius of the sprocket. The radius of the sprocket will change depending on the gear the bike is in, but we'll come back to that later. Anyway, chain tension times the radius of the wheel equals the torque about the sprocket.
Alright, all of these calculations are about to pay off, but before they do, we must calculate the drive force. But before this, we have to assume that there's enough friction between the rear wheel and the floor to prevent the wheel from slipping. Alright, to calculate it, you take the torque about the sprocket and divide it by the radius of the back wheel. So 86.36 newton meters divided by 0.3556 meters gives us 242.857143 newtons.
With 242.857 newtons being the drive force, if we divide it by the sum of the mass of the person riding the bike and the mass of the bike, which is 81.607 kilograms, we get an acceleration of 2.975 meters per second. And we are done.
Whew, that was a lot. And remember earlier when we said that the radius of the sprocket depends on which gear the bike is in? If we switch the bike to the 6th gear, the radius of the sprocket will
decrease,
which is now a new acceleration
of 2.6806585 meters per second.
This makes sense since you typically would choose a high gear if you want to go faster. And there you have it, a little something you can do with torque and bikes. If you guys like this video, smash that like button, hit the subscribe button, and ring the bell button. And we'll see you guys next time on